Okay, so we looked at the relativistic expression for energy, which looks like that. Well, let's write this in terms of E equals something, and then let's evaluate. Let's try to make contact with the energy that we wrote at the beginning, which looks like that, which is sort of the beginning of quantum physics for a particle that's free, has zero potential, and is non-relativistic. So let's see where the contact comes from. So let's try to isolate the energy. So E squared equals, right, we'll bring this to that side, we'll multiply by C squared, so E squared equals P squared C squared plus M squared C to the fourth. We can write P as mv, and so P squared becomes M squared V squared, C squared plus M squared C to the fourth. This is M squared C squared, which is a common factor. We can pull that out. It gives us V squared plus C squared. Let me pull another factor of C squared out. So we get M squared C to the fourth times V squared over C squared plus 1. And so we can say that E is equal to the square root of this, which is mc squared times 1 plus V over C squared. Well, square brackets to the 1/2. And right, the low velocity limit, we know this is the non-relativistic, so it's going to be a low velocity limit. Well, we'll show that. Plus some further action, but let's Taylor expand. So we need this is a function of V as V goes to 0, and that will give us energy at V equals 0 plus the derivative of this in V evaluated at V equals 0 times V minus 0. So it's V plus the second derivative evaluated at V equals 0 divided by 2 times V minus 0 squared plus ... which we can ignore. And so E of 0 is equal to, this is 0, so it's just mc squared, right? It's just the rest mass energy. E prime of 0, where we want to evaluate it at 0. So, but let's write it as v, in terms of V, mc squared. We get a 1/2 times 1 plus V over C squared to the minus 1/2 times 2 V over C squared. That's equal to M V1 plus V over C squared minus 1/2, which at V equals, evaluated at V equals 0, somewhat strange notation. Obviously, here makes the entire thing 0. Second derivative in V evaluated at V equals 0 gives us M times 1 plus V over C squared to the minus 1/2. We get a minus M over 2V 1 plus V over C squared to the minus 3/2 2v. That evaluated v equals 0 is, is equal to m times 1 plus v squared over c squared to the minus 1/2 minus mv squared over c squared times the same thing, well, to the minus 3/2. And so evaluated v equals 0, we get just m. And so our energy expression at low values of v is mc squared, this, plus m, plus m over 2 v squared, which is this mc squared rest mass term plus the p squared over 2m, which is our starting point for quantum physics and the free particle. And notice that, so this is almost the low velocity limit. There's the additional step of ignoring the rest mass in the non-relativistic quantum course.